right. Lecture 2 of Unit 1, Variables and Data Types. All right, up to now we've learned print and print line statements. Now, as cool as that is, that's like a 10-second cool. We want to be able to do bigger, better things, so we got to learn more. So what are we going to learn? Variables and data types. All right, so what is a type? It's a set of values. So in math, for example, we have real numbers, we have imaginary numbers, we have natural numbers, rational numbers, irrational numbers, right? We have these types of numbers. In programming, in Java, we also have types, and based on their characteristics will determine what type they are. So we have integers, so like numbers without decimals, 5, -5, 7. We have something called floats, and those are our decimal values. And then we have operations that we can do, addition, subtraction, multiplication, division, etc., to combine these to get new values. Now, one thing that you need to remember is that in a computer we have a finite amount of memory, which means we're going to not have an infinite number of possible numeric representations. We have a finite number. And so for integers, depending on the data type you use, we have a limited range of values. And for float values, again, we have a limited range of values. Not only that, though, not every decimal numeric value is going to be able to represent it. All right? So we'll get more into that. But we have two types of data types. Primitive data types are built in to the programming language. Byte, short, int, long, float, double, Boolean, and a char. All right. The ones that we're going to use in this course are going to be more limited than that. For our integer type, we're going to look at ints, and for floating types, we're going to look at doubles, and then we're going to look at booleans, and then single characters would be char or car, depending on your pronunciation. Also, Boolean, true or false values. Reference types are more robust. We've already looked at a reference type, string. A string is a set of characters inside double quotations. We're also going to start to make our own reference types, and we're going to do that later in the course. But just realize that we have these built-in types, and we can also create types. So like I was saying, the ones in this course that we're going to focus on, the data types are int, double, and Boolean. Int store integers. Pretty simple. Doubles store floating point numbers. They're decimal numbers, but like I said, not every decimal number is going to be stored precisely in the computer. And then Booleans are true or false values. So let's look at this example. We have a class named receipt, and we have a main method, and then we have a bunch of statements, a bunch of print line statements, because really that's all we've learned at this point. Now let's say I wanted to calculate my bill, assuming that there's an 8% tax and a 15% tip. And so here, for example, this might be me adding up what I bought, and then calculating the tax on that, and then calculating the tip on that, and then doing it all in one line to figure out my bill. So many print line statements, so many numbers. And then what happens if, like, later on, instead of $38, I'm like, ooh, that was actually only $36. Well, I'd have to replace it here, 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 here. Now, the whole idea of writing a program is to make our life easier, not more complicated, not more work. So what do? We use variables. Variables will make our life simpler. So a variable is a piece of the computer's memory. It's given a name and a type, and it can store value. All right, so there's 3 steps. You declare it. So is it an int? Is it a double? Is it a Boolean? And you also state the name of it. So for an int, I might have something called age. For a double, I might have tax rate. For a Boolean, I might have something that says is on sale. And then you initialize it. What do you want the tax rate to be? What do you want the age to be? What do you want is on sale to be true or false. And then you use it. All right. So when we declare it, we select the type and then name it. And the name is an identifier. So here, if I wanted to declare a variable, I could say int age, double call tax rate. I could say, or actually, let's make it more relevant, num items, tax rate, and then a Boolean is on sale. All right, so this is me declaring the type and then selecting an identifier name. Now, identifier names by convention start with lowercase letter, and then we use camel case, meaning additional words will be uppercase. In some programming languages, you might see them use underscores, like in Python, but here we use something more like this. So again, this is conventions. It's not Java's rules. It's Ms. Gilroy's rules that we abide by. All right, so this is an example of me declaring 3 different variables. An int can store integer values, a double can store decimal values, and a Boolean can store true, false. That's it. All right. And so what I've done basically is I've made a spot in memory that I can now go and access and assign values to, and then I can also retrieve those values. And so the way I do that is I assign a value to it. I store a value in the variable. So like here, int num items. Let's say I want to get 5 items. So num items gets 5. Now this, I say the word gets. Don't say equals. Equals sounds like equality, and equality is just shown some other way in here. So the memory location that I'm calling num items is going to get the value 5. Let's say the tax rate is going to get 0.08. So that means somewhere in memory I have a memory location that I've given a name and I've stored this value in it. And then is on sale, I can say true, which you'll notice it turns purple, or false, which you notice that it turns purple. And the way I've worded this basically tells the user that it's either going to be yes or no. It's either on sale or it's not. All right, so with Booleans, I tend to like to say is at the front of my Boolean variable names, just because it's normally a question, yes or no question. All right, so that's how you assign values. Now, what if later on I'm like, oh, I don't want it to be 5, then I can do some calculations to it. I could say that the tax, or the number of items I'm getting, is 5 plus 2, which is 7. So why couldn't I have said 7? Because I'm just trying to prove a point right now. So you could have expressions, mathematical expressions, as part of your assignment statement. So num items is going to get whatever 5 plus 2 is. So num items is going to get 7. All right. So when I use the variables, I can use them as part of other expressions. And so one option is to print them. And so what I'm going to do here is I'm going to show you how I can print the number of items. Now, if I were to say this, num items, this is a string literal. It is going to literally print the characters in here, which is the word num items. So what if I wanted it to get the value that's stored in the variable? Well, I'm going to put this little plus sign, and this plus sign is called concatenation. We'll talk more about concatenation later. But if I put this not in quotation marks, it's not a string literal. Instead, it's referring to my variable. And it's going to retrieve the value that is stored in num items. So now, if I were to run this, you will notice that down here, it's going to literally print num items because I told it to inside quotation, and then it's going to display a 7 because I asked it to. And remember, if you want to print a space, you got to put that space inside quotation marks. And so now when I run it, it says num items space 7. All right, so you can put these inside your print line statements. I can also do calculations inside my print line statements. The thing about doing calculations and print line statements is it's a one and done. In other words, I can't go back and change it. Like here, if I say num items times 3, and when I compile and I run it, it'll say 21. But you'll notice that if I were to print here, it'll still say num items is 7. And the reason is I never assigned num items the new value. And so whenever you want to update your variable, you have to do an assignment statement. Doing something like this is just an expression. It's not changing num items, it's just retrieving the value that's in there and substituting it into the expression. So every time you want to update your variable, you have to do an assignment statement. And in fact, you will do assignment statements plenty. So here I can assign a value more than once. So like for example, here I assigned x to get 3 and I displayed it, and then I changed x to be whatever 4 plus 7 is, which is 11, and so now it's 11. So we could change it. And so if I wanted this to happen, if I actually wanted this to happen, I would have to say num items is going to get whatever num items times 3 is. Now notice this does not make sense in math. This is not a true statement. Num items equals num items times 3. That's probably the case when num item, like when it's 0. That's probably the only situation in which that's the true statement. But what's happening here is you do your calculation with the current value of num items and you multiply by 3, and then you assign it back to that memory location. So you're essentially replacing what used to be there with a new updated value. And so you'll notice here it will say 21, and that's only because I assigned it to be that way. All right. Now, you can also declare and initialize in one statement. Here I did it in 2 lines. I declared that I was going to have a variable num items that had a data type of int, and then I assigned it. You can also do it in 1 line, which I'll come down here for this one, and I'll show you how that's done. Here I can just say double tax rate gets 0.08. And that is what you do when you know ahead of time what it is. This would be reserved more for like if you're going to wait until later on in your program and assign it a value. Okay, so you look here, you can see that we can do operations, simplify those operations, and then assign it to the variable. So like I mentioned, this equal sign is not equality. It means store the value into the variable. The variable gets that value. You always simplify the right-hand side, and then whatever that simplifies to, you assign it to the left side. You can also have multiple variables of the same type, and you could declare them at the same time. You can also initialize them at the same time. So if I wanted to do something like that, I could say something like int a, b, c. So here I'm declaring them in 1 line. I could also declare and assign at the same time if I wanted to. Now be very careful. Here x got a value of 3, y got a value of 2, z got a value of 1, but at this point in time a has no value assigned to it, b has no value assigned to it, c has no value assigned to it. So if I wanted to display the contents of what's in a, you'll notice that when I compile this, I'm going to get an error that says that my variable a may not have been initialized, and that's true. I never assigned it anything and never got a value. So if I fix that situation, you'll see that when I compile it, it'll display the value for a. So always make sure that if you're trying to use your variable at a different part of the program, that it's been initialized, that you've assigned it a value. Otherwise, you'll get a compiler error, and that'll be why. Okay? It's also important that a variable can only store something that matches its type. So an int can store integer values. It cannot store decimal values. And so if I tried to assign num items up here 5.3 and I compiled it, you would see that it says incompatible types, possible lossy conversion from double to int. And so that would be an error. On the flip side of that, though, if I were to say the tax rate was an 8, this one would not have a loss of precision. Instead, what would happen if I tried to display the tax rate, you'll see that this one will compile fine, and it will also display it. But instead of displaying it as an 8, it will display it as an 8.0. And that really comes down to the amount of memory that's reserved for an int versus a double. Not as much memory is reserved for an int, and so if you're trying to go from a double and place it in an int, you'll get an issue with storage. But if you put an int inside a double, it's fine, because a double takes up more memory, and so there's plenty of space for it. It's just they automatically convert it to a double for you. So compiler errors. Here we've declared x, and here you will get an error because what it's trying to do is assign the value of x to a variable 7. Now that's wrong in a lot of ways. 1, 7 is not a variable. 2, you cannot use a number to start off in an identifier name. Alright, another error that I showed you is if you don't assign your variable a value, you can't use it in a statement. And also you can't declare the same variable twice, and that's a mistake a student makes. When they just want to update the variable, they tend to declare it again, and really you just would say int x equals 3, and then in the next line x equals 5. So I showed you how you can print a variable's value. You can use words to represent words, but if you want to represent the actual value inside the variable, you do not put it inside quotation marks. And then to join the text with the variable, we use a plus sign. That's called concatenation. Alright, so let's go back to this receipt program, and so we have all of these things. And so what we can do is improve upon this. And the way we would improve upon it is we would try to represent these different things as variables. And so here you'll notice that we have a subtotal, and that way I don't have to keep adding it together. And then you have a tax rate of 8%, so we can multiply that by our subtotal, and then we take our subtotal to find the tip, and then we add it all together. Now that's one way of representing it by variables. You could represent it in another way, but here we're using 4 variables. The data types are int, double, 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 and so subtotal would get the result of this operation, and then the tax would take that current value and multiply it by 0.8, etc., and then you could display it. Our other data type is a Boolean, which is either true or false. So here, let's say we have a variable age that gets the value 22, and we say that the Boolean minor gets the result of checking if age is less than 21. Well, let's think about this. The variable age storing the value 22. Is 22 less than 21? And the answer is no. So minor would get false, and then I assigned Love's APCS to true. And so when I printed those results, it would display the words true or false. We also have the word final. Final is reserved for situations where we know it's a constant and cannot be changed. So think of constants that exist in math or in science. So pi is a perfect example. Pi is not going to change its value. If I know I always want to use this representation of pi, 3.14, in a program, then I can say, instead of just double pi, final. And that will allow me to prevent any possible mistakes and changes later on in the program. Now, by convention, we use all capital letters for constants, so that way people can quickly recognize them. And so you'll notice here, if I were to try to do that, I'd get a syntax error. Now, let's talk about conventions of naming variables. It should be descriptive enough to let the user know what is stored in the variable. X is not a good variable name unless you're talking, for example, about coordinates on a grid. So that would be an appropriate context to use X. But also don't use really long names, really crazy names, names that have nothing to do with your program, etc. You want it to be descriptive enough for someone to know. Now, convention is to start variables with lowercase letters and then uppercase any additional word. Do not put spaces. So because we don't use spaces, you uppercase each additional word after. We call that camel case. So here, num of lives, I use capital letters. Now, an option is to use underscore symbols, but I would prefer you to do this one and not this one. This one is more popular in other programming languages, but I want you to do this version. This is not incorrect, but it's also not what I want. Not every symbol can be used as an identifier name. You can't start your identifiers with numbers. You can't use spaces. You have a very limited number of characters you can use in addition. So you can use underscores, you can use dollar signs, but you can't use every single special character. We also have keywords, which are identifiers that cannot be used to name a variable because they already have a specific meaning. And we've seen these. Whenever they turn purple, these are reserved identifier names, or they're reserved words that you cannot use as identifier names. So I would never have a variable called void. I would never have a variable called public. I'd never have a variable called Boolean. It's just not allowed because they have their own purpose. And here's a list of them. But when you're typing your program, you'll see them turn color, and that's your clue as well. All right, I know that was a lot, but hopefully as you play around with variables this week, they start to make sense.